Hello, and welcome to Salts of the Earth, an 8-part video series on the issue of salt attack in adobe and earthen structures. My name is Eric Liefeld, and I'm with Mesilla Valley Preservation. We're a nonprofit organization dedicated to preserving the architectural legacy of the Mesilla Valley in southern New Mexico. So why do we care about salt attack? Because it can damage and even destroy buildings. As a nonprofit interested in the preservation of historic architecture, that matters to us. In the arid Southwest, much of our historic architecture is constructed of adobe. And while crystallizing salts can easily erode even very hard materials like stone, concrete, and fired brick, relatively soft adobe is particularly susceptible to the ravages of salt attack. This photo shows the collapsed wall of the San Jose Catholic Church in El Paso, Texas. Built in 1892, this building had been deemed structurally sound by professional engineers and was in the process of being rehabilitated when this collapse occurred. As we'll discuss in this video series, this collapse bears all of the obvious hallmarks of salt attack. After the wall collapsed in 2015, the 124-year-old building was subsequently condemned and demolished. This was a tragic loss to both parishioners and the community. Their house of worship is gone, as is a touchstone to the community's history. So what is salt attack, and why are we looking at a photo of the Sphinx? This is clearly Egypt and not southern New Mexico. It's important to understand that salt attack is a fundamentally natural process, driven by moisture, salts, and aridity, and that it has been around forever. Salt attack impacts important historical and cultural resources around the globe. Okay, but what does the Sphinx have to do with it? Well, the Sphinx illustrates just how long people have been combating salt attack. The Sphinx is an enigma on many levels, and its construction is a little mysterious too. It is both a natural formation and a man-made earthen construction. If you look closely, you'll see that the upper portion and the head of the Sphinx appear to have been carved out of solid limestone. Yet, if you look at the lower portions, you'll see that they are clearly comprised of masonry blocks. So which is it? Well, it's actually both. The explanation is fascinating. The Sphinx itself was originally carved from a limestone outcropping in something like 2520 to 2494 BC. It has been under attack from salts for millennia, likely since it was built. Why? Because the limestone outcropping itself is the remnant of an old seafloor. The residual salts and the aridity of the climate have steadily attacked and eroded the surface of the Sphinx, turning the solid limestone into what archaeologists call Sphinx dust. It turns out that those masonry blocks along the bottom were literally placed there by Egyptians, Greeks, and Romans. Yes, people have been trying to repair and save the Sphinx for millennia. Note how even the stone tablet is now so degraded as to be undecipherable along the bottom. This is another sign of salt attack, which you will soon begin to recognize. So, salt attack is not a new problem, rather it's a natural phenomenon. It is well known in preservation circles around the world, in places like Venice, Egypt, and Australia. The scientific understanding of crystal formation in porous materials is also robust. Somehow, salt attack has remained a little obscure and underappreciated in adobe preservation circles, which we hope to address with this video series. Unfortunately, ignoring salts or employing poor remediation practices can have dire results, as we've seen. Ignoring or misunderstanding salts can result in failed treatments and unnecessary expense. In southern New Mexico, we frequently see people repeatedly repairing and replastering buildings that are undergoing salt attack on a very frequent basis. This ultimately leads to frustrated and unhappy clients. Unfortunately, adobe and associated earthen technologies can begin to get a bad name as maintenance costs climb. Ultimately, as we've seen, historic structures can be lost to salt attack. Even new masonry structures are not immune. As I mentioned, salts can and do attack harder materials like stone, concrete, and brick. When the conditions are right for salt attack, even the modern built environment is at risk. In this video series, we hope to answer some fundamental questions. How does the salt attack process work? What does salt damage look like, and how can we identify it? We'll also look at MVP's field kit and methodology for detecting and precisely measuring salt loads in adobe walls. We'll review ways that we can use the field test kit to help us target salts for removal, ultimately setting the clock back for affected structures. Finally, we'll look at remediation and at ways that we can migrate salts out of load-bearing structure using permeable renders and other sacrificial elements. Thank you for watching this brief introductory video, and we hope you'll join us for the rest of the Salts of the Earth video series. And please consider subscribing to MVP's YouTube channel.